Hello.
Yeah, hello, sir.
Okay, you have sent the doubts, right?
Yes, sir.
So let's look at the first one. We have let S of k, where goes from 1 to 100.
So can you give me 1 second? I'll just get my
Yeah,
notebook. You give me 1 second.
here is the sum of the infinite geometric series. Sum of infinite geometric series whose first term is, what is the first term? 1 by k factorial.
So 1 second, let me just check. Uh, wait. 1 second. Sir, it's k minus 1 by k factorial.
Sure. This is the thing. Just check in the book properly because in the image it is not clear. First term is this, and common ratio is 1 by k. Can you see, is it this the first term?
Yes, sir. Yes, sir. It's k minus 1 by k factorial.
Okay, then they are asking us for value of 100 square by 100 factorial plus summation k goes from 1 to 100 mod of k square minus 3k plus 1 multiplied by s of k. What is the value of this? Okay, first of all, sum of infinite GP with common ratio like this. Common ratio is 1 by k. Okay, so S of k would be k minus 1 by k factorial by 1 minus 1 by k, right?
Yes, sir.
So basically this becomes what? K minus 1 by k. K minus 1 will get cancelled. So you have 1 by k factorial and you have 1 by k here, right? So this is 1
Yeah.
by k minus 1 factorial. This is your S of k, correct?
Yes, sir.
Or it is basically k by k factorial. Now we have to find out this sum. So this becomes k square minus 3k plus 1 by k minus 1 factorial mod of this summation goes from k is equal to 1 to 100 and 100 square by 100 factorial plus this. Okay. So we have to understand this summation part now. Okay, so k minus 1 factorial is always positive. K square minus 3k plus 1, however, that is equal to k minus 1 whole square minus k, right? Correct. This is
Yeah.
equal
Yes.
to k minus
Yeah.
1 whole square minus k. So this square for k is equal to 1, for example, what is coming? 0 minus 1. For k is equal to 2, what is coming? 1 minus 2, right?
1 minus 2.
And for k is equal to 3, you're getting 2 minus 1 whole square, 4 minus 3, 1, right?
Yes.
And for k is equal to 3, it came, k is equal to 3 was
2, 4,
this.
4.
2, k is equal to 1. In k is equal to 4, you're getting 9 minus
9
4, 5.
minus 5. Okay.
And now it will be increasing and it will be positive, right? So
Yes.
the first two terms are the only negative terms when k is equal to 1. So other terms are all positive. So this modulus has no meaning except for the first two terms, right?
Yes.
So for the first two terms, you can separately calculate it out, because you can say that it is k is equal to 1, it will be minus 1 by 0 factorial is 1, so 1 only, plus k is equal to 2, this is still minus 1 by 1 factorial, so still 1 only, right? After taking modulus. And after that, you have to do sum of k is equal to 3 onwards, 200 of this stuff, which is positive now.
Okay, yes.
Okay, this is the thing. And outside there is 100 square by 100 factorial also, which is added.
Yes.
Okay, so then we have to simplify this somehow, this summation.
So 0 factorial is 1 and 1 factorial is also 1.
You don't know this.
No, I know. The 0 factorial part I didn't know.
0 factorial is by definition 1.
Okay.
You need to know this. This is the standard fact of factorials. In order to simplify this, we can say that k minus 1 whole square minus k divided by k minus 1 factorial, and we can write that as k minus 1 whole square by k minus 1 factorial minus k by k minus 1 factorial. So this will become 1 of the k minus 1 can get cancelled. You have k minus 1 by k minus 2 factorial minus k by k minus 1 factorial, right?
Yes, sir.
This is following the same pattern. This term is one more than this term. So now you can do telescoping series easily, 3 to 100.
Yes, sir, can you explain that step again? How you got k is equal k minus 2 factorial? That step.
How is that not clear? K minus 1 factorial is not k minus 1 into k minus 2 factorial.
Yes, sir, it is.
So what will happen if I cancel
Okay,
this?
fine. Okay, that's okay.
That is an obvious thing. And we are getting these two terms. Why is this good? Because the top term is one more than the denominator. Both have denominator factorial, and top term is one more than the denominator, right?
Yes, sir. Yes, sir.
So it's the same pattern. So that means if you do telescoping series, it will start cancelling now. Because
Yeah.
if you do 3 now, what is the first term? K is equal to 3. You get on top 2 by 1 factorial minus 3 by 2 factorial. The next term when k is equal to 4 will be what? 3 by 2 factorial minus 4 by 3 factorial, which cancels. So obviously now the last term when you put 100, you get 99 by 98 factorial minus 100 by 99 factorial. So again, first term will cancel and you will be left with this, right?
Yes, sir.
Do you understand? There is only this and this left. 2 by 1 factorial minus 100 by 99 factorial. That is equal to the sum of this. We are getting it by doing simple method of difference. Right?
Yes.
Are you understanding what I'm saying?
Yes.
So finally, now adding everything, you have 100 square by 100 factorial plus 1 plus 1 plus 2 minus 100 by 99 factorial. 100 by 99 factorial is the same as this, because again, this is 100 by 99 factorial. Answer is 4.
Okay.
100 square by 100 factorial is equal to 100 by 99 factorial if you simplify and cancel 100. Right?
Yes, sir.
The answer is 4. The answer comes if you basically write the GP formula and then expand k square minus 3k plus 1 as k minus 1 whole square plus k. And then
So they're showing the answer as 3 to that question.
just check the calculations. The question is over. You have to just see the first term. K is equal to 1, K is equal to 2, check everything. Right?
Okay, sir. Yeah.
K is equal to 1. I don't think I don't think the SK term is only defined for K is equal to 1. You cannot have an infinite series with K is equal to 1. Then,
Oh.
like, you understand what I'm saying? Common ratio is 1,
Yeah.
then it is not a finite value, right?
Yes, sir. Yeah.
So actually the question is only slightly wrong, because then how can you define SK for K is equal to 1? You can't really.
Okay, so there's no
SK is not finite, no? Is infinite
sir.
for K is equal to 1. So you should
Yes.
ignore the K is equal to 1 term, right?
Yes, sir.
Because it doesn't make sense. You cannot define SK. So in the question only there is a slight issue then, I think. Right?
Yes.
Because infinite series common ratio is 1 by K. So if K is 1, it's not working. K is 2 onwards, it is defined, right?
Yeah. Okay. Yeah. Yeah. Understood.
Okay. Next one is Sn is equal to 1 into n minus 1 plus 2 into n minus 2, 3 into n minus 3, and so on. Plus n minus 1 into 1. The sum n is greater than equal to 4. You have to find the sum of n is equal to 4 to infinity of 2 Sn by n factorial minus 1 by n minus 2 factorial. This is very easy. You just have to find the Sn expression. Why are you unable to find Sn expression?
Sir, I thought of look like I tried to write a general term for this.
No, the general term is obviously that is the correct way to do it. R into n minus
Yes.
r. R goes from where to where? 1 to n minus 1.
Yes, sir.
Can you see this is it?
Yes, sir.
This is equal to Sn. It is very easy summation. Nr minus r square. Summation from 1 to n minus 1. You split it as two separate terms. Nr 1 to n minus 1 minus summation r square 1 to n minus 1. Do you know the formulas?
Yes, sir. I do. Yes.
1 to n minus 1 summation of r. What is that?
It is n into n plus 1 by 2.
That is for sum to n terms. What is about sum to n minus 1 terms? It will be n minus 1
n
into
minus 1.
n minus 1 plus 1, which is n by 2.
Yeah.
Minus, this is the formula n plus 1 to n plus 1 by 6. But instead of n, I have to put n minus 1.
Minus 1.
N minus 1, n plus 1 will become n. 2n plus 1 will become 2n minus 2 plus 1. So 2n minus 1 by 6. Right?
Yes, sir.
This is the summation. You simplify the summation a little bit by taking n into n minus 1 by 2 common. You will be left with here n minus n into n minus 1 by 2 common. So it will be 2n minus 1 by 3. So it will be 3n minus 2n. So n plus 1 by 3, right?
Yes, sir.
So the thing is n into n square minus 1 by 6. That is my Sn. If you calculate this, right?
Yes. Yeah.
So 2Sn is basically what? 2Sn is n into n square minus 1 by 3. So after that, you have to calculate it. N into n square minus 1 by 3 n factorial. 3 is separate and n factorial is separate. Minus 1 by n minus 2 factorial. N factorial 1 you can cancel. It becomes n minus 1 factorial. Again, this
Yes.
also n plus 1, n minus 1 you can cancel. It becomes n minus 2 factorial, right?
Yeah. Yes, sir.
So you're getting n plus 1 by 3 by n minus 2 factorial minus 1 by n minus 2 factorial. So that is basically going to become n plus 1 by 3 minus 1 by n minus 2 factorial, right?
Yes, sir.
So this becomes what? N plus 1 minus 3, so n minus 2 by 3. So it is n minus 2 by 3 or n minus 2 factorial, which becomes n minus 3 factorial, right?
Yes, sir. Yeah.
The whole expression is basically 1 by 3 times n minus 3 factorial. And you have to do summation. 1 by 3 comes out. You have a summation. 1 by 3 comes out 4 to infinity 1 by n minus 3 factorial. Right?
Yes, sir.
So basically, this is when you start with 4, you get 1 by 1 factorial plus 1 by 2 factorial, so on, so on. You have to do the infinite sum, and outside there is a 1 by 3. Correct?
Yes, sir.
How do you do this infinite sum? What is this sum? Can you see that this sum is becoming this only is that?
Okay, yeah. So that should be equal to 1,
No,
I think.
it is not equal to 1. This part you need to know that the expansion of e power x. This is not something that you know right now, but later in 12th grade you will learn the Taylor series expansion of e power x. Taylor series, and a power x expansion is 1 plus x power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. So till infinity. This is standard stuff, but you don't know it right now because you're not in 12th. So here, if you know this, then you can see that if you put x is equal to 1, what happens? E power 1 is what? Right?
Yeah, yes, sir.
That is what it is here, except there is a missing 1. So this is equal to e minus 1, right?
Yeah.
So it is e minus 1 by 3. That will be the answer. Do you understand?
Yes,
The
sir.
main part of the problem is reducing it to this, which was not hard at all. There was nothing weird that I have done in doing this. It is all standard stuff to find till here. After this, you may not know the last step, which you will know in 12th grade. Do you understand?
Yes, sir.
But you should have been able to reduce it to this stage. If you're not able to reduce it to this stage, that means you have made some silly mistake somewhere. Is it clear?
Yes, sir.
Okay. Next one is A1, A2, A3 are in AP. A1, A2, A3 is in AP and so on. Such that, okay, A1 plus A2 till A1 plus A2 till AP P terms divided by A1 plus A2 till AQ Q terms is equal to P cube by Q cube, where P is not equal to Q. Okay, and then they're asking you for A6 by A21, right?
Yes.
Such that this P is not equal to Q. A6 by A21. So this sum can be written as basically, I mean, we have to think of what will be the best way to write it. So you can say P by 2. Okay, let's just write it like this. P by 2, 2A1 plus P minus 1 into D, right?
Yes, sir. Yeah.
And Q by 2, 2A1 plus Q minus 1 into D is equal to P square by Q square. Since P is not equal to Q, this P by Q and all will cancel, right?
Yeah, yes.
This will cancel. This is already going to become P square by Q. So it should have been P cube by Q cube, right?
Yeah. Yes, sir.
This is P square by Q square. Now you can simplify. Did you try simplifying this?
Yes, sir. I tried. Tried cross
That you
multiply.
tried.
I tried cross multiply. Yeah.
So 2A1 into Q square minus P square is equal to, here when you take it on one side, D into P square Q minus 1 minus P minus 1 Q square. we are getting this. This is becoming p square q minus pq square minus p square plus q square. So this is clearly pq common q minus p plus q minus p into q plus p. And you are getting q minus p common throughout. This pq plus q plus p and multiplied by d is equal to 2a1 into q square minus p square. Since q is not equal to p, q minus p can be cancelled. You have q plus p here. So you are getting pq plus q plus p into d is equal to 2a1 into q plus p, right?
Yes, sir.
Okay. So that tells us what? PQ so we can say +1 -1 if I put, I will get this will become q p plus 1 plus q plus 1 p plus 1 minus 1 into d is equal to a1 p plus q. We are supposed to find a6 by a21,
A21. Yeah.
which is a1 plus 5d by a1 plus 20d. Okay, so which is a1 by d plus 5 by a1 by d plus 20. And from here I'm getting a1 by d is equal to pq plus p plus q by 2p plus 2q. Right?
Yes.
pq plus p plus q plus. So we have pq plus p plus q plus 5 by pq 2p plus 2q. No. This is a1 by d, so you have to add 5 like that. Okay. We want to find the value of a1 by d plus 5 by a1 by d plus 20. So on top you are getting pq plus p plus q plus 10p plus 10q, so plus 11p plus 11q. And on the denominator you are getting pq plus pq plus 40p 41p plus 41q. Okay, so plus 121 minus 121 plus 1681 minus 1681. Write this as p plus 11 q plus 11. minus 121 by P plus 41 Q plus 41 minus 1681. This is the ratio, no. This result is true for any P and Q, okay?
Yes.
Or only for specific P and Q. If it is true for any P and Q, then we could have just put some. If it is true for all P and Q, which is not specified in the problem, they have not said that. Again, they have not written the full question properly. Let A1, A2 be an AP such that this is equal to, and nothing they have said about for all values of P and Q or what. If it is a specific value of P and Q, we can't do anything beyond this. Do you understand what I'm saying?
Yes, sir.
If it is any value of P and Q, then obviously we will be able to find the ratio because we can take P as 2 and Q as 3 and P as 4 and Q as 5 or whatever you want, right?
Yeah, yes, sir.
Because then A1 by D has to be constant regardless. A1 by D is fixed for the different values of P and Q, it will be fixed. So suppose P is 2 and Q is 3, what will happen? You'll get P is 2, Q is 3. What is coming here? 2 into 3 is 6 plus 2 plus 3, 11 by 2 times P plus Q, 2 times 5, 10. A1 by D will be 10. In that case, the ratio would be 11 by 10 plus 5 by 11 by 10 plus 20. You'll get 50 plus 61 by, here you'll get 200 plus 11, 211 in that case, right?
Yes, sir.
But something is missing in the question. It doesn't seem right. I mean, answer will be 121 by 1681. Right? Answer is third one, right?
So one second. Yes, one. Yes, sir. It's third one.
But it is not very clear why. We are getting this. This is fine, but if it is true for different values of P and Q, then every time you will get a different common ratio and all. Yeah, I'll think about it. Maybe there is some trick to it. I don't know. But
Are
right
they
now,
asking us to substitute values in the? Because it wouldn't be 11, option 2 and option 4 because they are not perfect squares. So,
no, it will be option 3 only because
yeah.
if you see here, the factorization is happening only with 121 and 1681. But still, that doesn't, it's not equal to it.
Yes, yeah.
Something is going wrong. Okay, I'll try that later. Let's go to the next ones. Sum of the series n is equal to 1 to infinity n square plus 6n plus 10 by 2n plus 1 factorial. Again, as soon as there is a factorial amount, see the answers have E and all. So you again have to use this
Yeah, so
later.
that's actually okay, fine. That's all I
At the
needed to know
end, you
where.
will have to use this
Yeah, yeah. I understood.
because this is basically saying that sum of x power r by r factorial, where r goes from 0 to infinity, is equal to E, is equal to E power x. So you put the value of x, you'll get the relevant thing. So this is a fact that you need to know.
Yes, sir.
But to simplify it and all, what can we do? We can say here 6 and 10. So we can just write n plus 3 square plus 1, right?
Yes, yeah.
N plus 3 square plus 1.
And
It would have been nice if he had 2n plus 1 or somehow. So that would have been 4n square plus 4n plus 1. So if I do a 1 by 4 and 4n squared plus 24n plus 40, out of which I can take 4n squared plus 4n plus 1. And what will be left? What will be left is 20n plus 39, right?
yes.
What am I doing? I put a 1 by 4 and multiply it by 4 and split it like this, right?
Okay.
Why am I doing it? Because here it will become 2n plus 1 whole square plus, you can write this as 20n plus 10. So 2n plus 1, right? 10
Yes.
common.
Yeah.
And plus 29, right?
Okay, yes.
So whole thing is divided by 2n plus 1 factorial, 2n plus 1 factorial, 2n plus 1 factorial. And then you can simplify it as 2n plus 1 by 2n factorial. We cancel one factor. And then this is 10 by 2n factorial, right?
Yeah.
And 29 by 2n plus 1 factorial. Now 2n plus 1 by 2n factorial can be split again as 2n by 2n factorial plus 1 by 2n factorial plus 10 by 2n, so 11 by 2n factorial plus 29 by 2n plus 1 factorial. And 2n by 2n factorial is 1 by 2n minus
2n
1
minus
factorial
1.
plus 29 by 2n plus 1 factorial plus 11 by 2n factorial. After this point, you have to write the relevant series. This is like the odd number terms. All the odd powers are there.
Yeah.
This is also odd powers only. N starts from 1, but you'll be missing some powers. It will become a little annoying, but you'll have to use this series to figure it out now.
Okay.
You can say e power minus 1 is what? 1. Instead of x, you are putting minus 1. So 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on. Right?
Yes, sir.
You have to see the options and see which ones are working out. Again, this is not at the level that you are currently at, so you cannot do it right now. You don't know the E stuff.
Okay, yes.
Let's go to the next one. Next one is number of terms of an AP is even. Number of terms n is even. The sum of odd terms in it is 24. Sum of odd terms of the AP is equal to 24. And that of even terms, sum of even terms is 30. Is equal to 30. And the last term exceeds the first term. an minus a1 is equal to 10 and a half. So 21 by 2. Find the number of terms. The sum of odd terms is what? A1 plus A3 plus so on till A of n minus 1 because n is even. right?
Yes, sir.
N is equal to 2k, you can say, and this is becoming a1 plus a3 plus a5 till a of 2k minus 1. That is equal to 24. And a2 plus a4 plus a6 till a of 2k is becoming 30. And this is given also a of 2k minus a of 1 is equal to 21 by 2. Right?
Yes, sir.
Obviously, the total sum of the series is 54. So a1 plus a2 till a2k is equal to 54. So that will be basically 2k by 2 a1 plus a2k, right?
Yeah, yes.
N by 2 first term plus last term, that is the sum of an AP. So
Yes.
we are getting k into a1 plus a2k is equal to 54. And from here, we are getting a2k minus a1 also, right?
Yes, sir.
Okay. So a2k minus a1 would be, this will be a1 plus 2k minus 1 d minus a1. So 2k minus 1 into d is equal to 21 by 2. So d is 21 by 2 into 2k minus 1. And from here, we can say k times a1 plus a2k would be 2a1 this is the d. This is the 2a1 and all. So this cancels this. 2a1 plus 21 by 2 is 54 by k. Hmm. Okay, there will be a nicer way to do it. 1 second. Sum of odd terms is 24. Sum of even terms is 30. And number of terms is even. And last term minus first term is equal to 10 and a half. So that is basically n minus 1 into d. A1 plus n minus 1 into d is this. So is 21 by 2. This is the first equation. And if there will be basically n by 2, and n by 2 terms here, right?
Yeah, yes.
The only difference is this starts from a1, this starts from a2, right?
Yeah.
So this is n by 2. This is going to be first term 2a1 plus n by 2 minus 1 into d, that is 24. And this is n by 2. First term is now 2a2 plus again there are n by 2 terms, right?
Yeah.
Is equal to 30, right? So if you
Yes.
divide these two equations, you will get 4 by 5 is equal to 2a1 plus n by 2 minus 1d divided by, this is a2 is equal to a1 plus d. So 2a2 is 2a1 plus 2d. So plus n by 2 minus 1 plus 2. So plus 1d, right?
Yeah, yes.
If we have this, we can do componendo and dividendo, right?
Okay. Yeah.
This is a by b is equal to c by d. So I can say it is 4 minus 5 minus 1 by 9 is equal to this minus this. Subtraction would be n by 2 minus n by 2 minus 1. So minus 2d by addition would be 4a1 plus addition would be n. This addition is nd, right?
Okay, yes.
Do you understand what I'm saying?
Yes, sir. Yeah.
So you're getting 4a1 plus nd minus cancels is equal to 18d. This is one equation, and here you have nd minus d is equal to 21 by 2, right?
Yes.
So, okay, so this equation, okay. So from here, we can say that nd is equal to d plus 21 by 2. So 41 plus d plus 21 by 2 is equal to 18d. So we are getting 4a1 plus 21 by 2 is equal to 17d, right?
Yes.
So 8a1 plus 21 is equal to 34d. We're getting this equation. A1 is equal to 34d minus 21 by 8. A1 and D are coming in terms of each other. And using this information in this equation, for example, you will get n by 2. 2a1 will be 34d minus 21 by 4 plus n by 2 minus 1 into d equal to 24. Still, you are getting d left over. Okay, 1 second. Let's just write the terms. A1, A3, A5, A n minus 1, and this is A2, A4, A6, AN. We can see, okay, it's very easy actually. We can see that this sum was 24 and this sum was 30, right?
Yes, sir.
What is this? All these terms are A1 plus D, A3 plus D and all, right?
Yeah.
So it is 24 plus ND, right? N by 2D.
Okay.
The
Yes.
number of
Yeah.
terms is what? Number of terms
N
is
by
N by 2. Every term is D ahead of the previous year, right?
Yes.
24 plus N by 2D is 30. So N by 2D is 6. So ND is 12. This is the extra information we needed, right? And then they have given us the difference between this and this term, right? Correct?
Yeah.
So that is
Yes.
basically what? AN is A1 plus N minus 1 D minus A1 is 10 by 2 and 21 by 2. So N minus 1 D, this is over now. ND minus D is equal to 21 by 2. So D is coming. 12 minus D is 21 by 2. So D is equal to 3 by 2. If D is 3 by 2, N is equal to 12 into 2 by 3. Right?
Okay. Yes. Okay.
There will be basically 8 terms. The idea is you can't solve it by equations. You have to basically use the fact that the sums are like that.
Okay.
The sum to 24 terms and sum to of all the odd and evens are given 24 and 30, right?
Yes.
So you have to use that information intelligently. That's the whole thing. Otherwise, the equations become very annoying, right?
Yes, sir. Yeah.
Okay, then there is some physics stuff.
Yes,
At
sir.
time 0 second, particle starts moving along x-axis. Kinetic energy increases uniformly with time t. The force acting must kinetic energy is equal to some constant into time, increases uniformly with time. Force acting they are asking must be proportional to what, right? So half
Yeah.
mv square is equal to AT, you're getting V square is proportional to T, right? Something.
Yes, yeah.
So obviously V is proportional to some K into root T. So dV by dt will be proportional to 1 by 2 root T. So this is the acceleration. The force will be proportional to what? 1 by root 2 root T. Right?
Oh, okay.
If
Okay.
kinetic energy is like this, velocity is proportional to root T. So acceleration is proportional to 1 by root T. If acceleration you will get proportionality of force, right?
Yes, sir.
Next one is 70 kg man lifts vertically from a crouching position to take a leap. Man pushes the ground with a constant force F to raise himself. Center of gravity rises by this much before he leaps. After the leap, he rises by another 1 meter. Okay, maximum power delivered by the muscles. So, see, to lift himself, he was in a crouching position, let's say. Man, the center of gravity is, let's say, here. By the time he's about to jump, he will be standing, right? By the time
Yes.
he's about to jump, he'll be standing. His center of gravity will have been risen by some amount, right? 0.5
Okay.
meter, right? Correct?
Yes, sir.
And
Yes, sir.
then he leaves contact with the air with this, and then he rises up to a certain height. He must have acquired some velocity so that he's able to jump now, right? By the time he is here. He has not started covering distance, but he's acquired a velocity somehow, right?
Yes, sir.
Then only he rises up like this, and he rises up by a height of 1 meter, right? So when he's
Yeah.
flying in the air and he has covered 1 meter, only force acting on him was gravity, right?
Yes, sir.
So we can estimate the velocity with which he jumped off, right? So that he reached 1 meter high, right?
Okay, yeah.
So we can say that the velocity with which he jumped off would have been what? V square. Final is 0, V square minus 2 into G into 1. So V is equal to root 20, right?
Yes.
That was the velocity that he has acquired here. Then only he can rise up to 1 meter height, right?
Yeah, yeah.
So if you think about it, how did he acquire this velocity? Because he exerted force F on the ground and ground basically pushed him F with force, right?
Yes, sir.
Also at the same time, gravity was acting downward, but his center of mass has risen. So work is done by gravity also, right?
Yeah, yeah.
So you can say that there are two forces doing work on the man while he starts to jump from crouching position to standing position. That is work done by force of F that he exerts on the ground, which ground exerts on him, right?
Yeah.
And mg force. So you can say work done by F plus work done by gravity should be change in kinetic energy, right? This is called work energy theorem.
Yeah.
So work done by force F is equal to change in kinetic energy minus work done by gravity. Work done by gravity from where to where? From the crouching position to the standing position, right?
Yeah.
Work done by gravity is equal to negative of change in potential energy. So it is U initial minus U final. If you take this as the 0 level initial, this is going to be higher level. So work done by gravity is negative minus 70 into 10 into half, right?
Yeah. Yes, sir.
Final potential energy is this, right? Initial
Yes.
is 0 if you take this as 0 level. So this becomes basically minus 350 joule. So you get change in kinetic energy is the final velocity at this location minus initial velocity was 0. So half into 70 into V square is 20 minus work done by gravity is negative. So plus 350, right?
Yeah.
So this is 700 plus 350. And this is 1050 basically joule. This is the work done by force F, right?
Yes.
And this happened in the time that the man used the constant force and all, right? This happened in the small time, right?
Yes, sir.
So you have to now estimate how much time it took to acquire this velocity v, right? Because notice that you have covered higher, you have gone up by 0.5 meter, and in that time you have acquired this much velocity, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
Center of mass has gone up by 0.5 meter and you have acquired this velocity. So you can say v square is equal to u square plus 2a. So 20 is equal to 0 plus 2 into a into half. That means acceleration is 20, right?
Yes, sir.
If your acceleration was 20, the force must have been what? M into a. No, force must have been even higher, right? Because you are, the equation on u is F minus mg is equal to ma, right?
Yes.
So force is equal to m into g plus a, right? That's how you have gotten an upward acceleration of a, no?
Yeah.
So force is equal to 70 into g plus a. G is 10, 70 into 30. So which is basically 2100 force, right?
Yes, sir.
Correct. Maximum power delivered. Maximum power delivered is basically
Force into
force into
velocity.
velocity. So maximum velocity is here, right?
Yes.
Maximum velocity is at the highest point here. If you are accelerating from 0 velocity to root 20 velocity, right? So 2100 into root 20, which is basically 2 root 5. So this is 4200 into root 5, which is 2.236. So it is come something 8500 something.
Okay.
The answer is not like that. So you have to check now. F into root 20 is what? 2 root 5, that's correct, only 4 point something. What is the answer given?
So one second.
At the takeoff point is the answer. It will be second option, right?
Okay. One second. Let me check.
We can even estimate it as
This is the third option.
what is the answer there?
The 9.3 into.
Okay,
third
then that
option.
is correct, no? See?
Yeah.
4002, I didn't see that third option is not visible to me in the picture. So 4.2,
Oh.
4200 into 2.236 is coming 9000 roughly if you calculate.
Okay. Okay.
Right? Because 1 by 5 of this is almost going to be 800. 2.2 of this. So 8400 plus 800, 9200 something, right?
Yes.
You understand what I've done?
Yes, sir.
The question is about from the crouching position to the standing position, the man is accelerating somehow. His velocity has increased. Then only he is able to jump. So first of all, you need to find out how much was his velocity at the point he was about to jump. That velocity we found out by doing this stuff. Once we found that velocity, actually this work calculation was not even required, right? This I have done, but in case they had asked something else, you would have needed it. But this is not required for the question. Once you found the velocity, you can find the acceleration because the person has accelerated with a constant force from this position to this position. So 0.5 meter distance was covered and you acquired this much velocity. So acceleration is obvious. Acceleration came out as 20. If acceleration came out as 20, power by that force is F into V. And V is constantly increasing. So maximum power is at the takeoff point here. Which is, and F, how did I find? F minus mg is equal to ma. F is equal to m into g plus a. Right?
Yeah.
Your F is not equal to mg. It has to be bigger than mg. Then only you are accelerating upwards. Right?
Yes, sir.
Okay. Fine. The remaining questions we'll discuss in the next class. Get all the other doubts also, whatever is there.
Yes, sir.
Fine. That's all for now then.
Okay.
Hmm.
Thank you, sir.
Bye.